that are leveraging 4G and Wi-Fi systems to actually deliver all kinds of information, both from the car back to the manufacturer or back to the services that you're actually trying to drive, or to the car, basically in giving you route information or traffic information or any of those types of things. So basically, that's a lot of software running on very sophisticated processors that, as I said, are as powerful as the things that are at everybody's desk and in everybody's server farm today.
And the part managing the cloud.
Part of the standardization of the delivery of that kind of capability will come through what we learn in standardizing architectures around cloud deployments.
I also think it's, from an automotive perspective, the new thing as well is it's an evolution from actually putting things on chips or singularly creating modules that create different functions, but it's actually moving to a functional design approach. So that really is a difference. Instead of just bolting on these modules and including more and more software and putting more and more things on chips, it's really systems on chips delivering functions, and the way in which the vehicle is architected, the way in which it's put together, and the way in which it's designed is much more of a functional orientation versus just for it to be a vehicle that can get you from point A to point B. And the importance of all the software Danny described and all these systems coming in is moving the design approach to that functional approach so that the vehicle can be much more efficiently designed and developed in a more cost-effective way. Because there's at some point it's just going to get out of control. It'll no longer be able to be contained. That's the difference, I think, of the different approaches we see being required for these industries. It's really changing the way in which they design the products.
Right. Let me give you a very simple example. It's a very graphic example, but it's a very simple one. The design of MP3 players. Okay? When you think of an MP3 player, and you think of it from the electromechanical perspective, pure electromechanical perspective, and you throw in a little bit of software, what do you get? You get a device that can play songs. When you think of it from a functional, software-driven, interconnected device perspective, what do you get? You get an iPod that becomes an iPhone. And you disrupt Walmart and Sony as the distributors of electronic and digital music. Okay? And I think that kind of disruption is going to drive the evolution of many different industries. And if you look at it as a bunch of products that are mapped to physical constraints, and you don't think of it as optimizing the local perceived quality by the end user that then integrates all of those logical services and optimizes the experience of that particular user, i.e. the functional experience, you're going to see a lot of people that are going to get disrupted in various industries. Yes?
Tony Bear with Ovum. I'd like to pick up from Melinda's question before about the integrated product framework. Of course, there's certainly a need to figure out how to rationalize all the rational offerings in that space. But of course, so does it. But I want to get irrational for a second, which is that, of course, when you're dealing in the product domain, you're dealing with lots of existing information silos and domains in mechanical engineering, electrical engineering. We have a very well-established supplier base. They're also trying to go up the stack as well. But I'm wondering, in this framework, do you have any links or alliances with any of the major providers there, say like the PTCs of the world, the SOs, Siemens, so on?
I do. It's really, it's the heart of what we're trying to achieve. We really are trying to think differently about the problem, and no longer is it a mechanical system. It really needs to be approached differently. So when you think about it from the approach, and you look at it from a system perspective at the highest level, and then you go to where's the value, and you go to the software, and then you talk about how you enable the software through circuit boards and physical mechanical packaging. When you look at it from that approach, approach, then you can start to see where everyone fits into the value chain. And what we're trying to achieve, since we really have come about it, our experiences from a software perspective, and since software is driving all the innovation in the products today across all these industries, we really are trying to create a data backbone for the actual artifacts and or nuggets for each of those domains of design to be able to be released. So whether it's from a mechanical packaging, which those elements are really important, so we're not trying to minimize that, but or an electrical circuit board for the connections, or the software from a control logic or control theory perspective, all those have to relate on this backbone in a seamless way. So we're creating a series of solutions that surround all of the design domains and are able to actually free all of these pieces of artifacts and or particular data models that are needed throughout the design process, and allows us not to get pigeonholed into any one, design focus or proclivity. With that, we are partnering with multiple players across each of those design domains for us to be able to more seamlessly lift the importance of the data, allow those tools to have the proper place in the design value chain, as well as the proper place in each of those organizations, but lift off the important things that are needed so that software and the system can be in focus at a functional level, and all of the pieces of data can certainly be used in an appropriate way, at the right sequence, at the right time, and in parallel versus in serial, which is what typically happens today.
Yeah, now, if you want to take a look at a lot of those suppliers of software systems themselves, because whether it's a PTC, a Siemens, or a Dassault, they provide an underlying software system that then optimizes what I think of as physical constraints. Okay, they haven't yet figured out that optimizing physical constraints doesn't necessarily translate to optimizing logical constraints. And so they're continuing to apply the same notions of physical optimization to logical transformation. And unfortunately, it's not working. So what happens is that, when we go to them to try and get them to partner with us on understanding that fundamental shift in value, they sometimes agree and they sometimes disagree. And I think that that's probably what you're alluding to, which is essentially we're still in the early stages of getting the market to understand that shift in transition. And as a result, we have the initial experiences at getting them to work with us, and we are building out that kind of integration, especially in high-tech electronics. So we have partners in high-tech electronics, like a Cadence Systems, that's actually building out extensive integrations with us through the OSLC layer, the Open Services for Lifecycle Collaboration layer. That is the open standard that we have published with well over 30 companies working together with us on the evolution of that particular standard. If you will, if you want to think of it, it's the Eclipse. The same approach that we took to Eclipse now manifesting itself for life cycle, not just integration on a desktop. So basically from that perspective, a lot of the folks are going to be pushed into that particular domain, pulled by the customers into it, not necessarily wanting to go nicely and quietly